So, good morning and good evening, everyone. Well, we'll begin the session in a moment. Before we actually start the session and explain the concepts, whatever we have to discuss today, let me briefly introduce myself. That will be a great idea. So, let's just run a slide. Yeah. So I hope you can see the slide. My name is Raghu, and this is my profile. So I'm working as a corporate trainer, mentor, and a subject matter expert on a variety of areas. In fact, I train people. Majority of the trainings that I handle are in cloud, big data, and DevOps. So when you talk about cloud computing, there I train people on Amazon Web Services. So as you might be aware, Amazon Web Services is one of the largest platforms of cloud services. And I also carry a little bit of expertise in Microsoft related cloud services, which includes Azure platform. And talking about big data, I have been into big data for past, say, 5 years or so. And most of my experience falls into the administration and development of Hadoop. But that is not limited to Hadoop. I do carry relevant expertise in other big data projects such as Spark, MongoDB, Cassandra, etc. And I also happen to be a little bit experienced on the front of DevOps. And overall, I have around 10 years of IT industry experience. I was working as a consultant and solution expert in a variety of fields, actually. And when I get free time, which is very less, I also author and create custom content for training organizations and vendors. So in the content development side, I typically design an end-to-end course or curriculum, which usually falls into the areas of virtualization or big data or Linux, etc., etc. So this is what I do. So mostly I'm into, you can say, most of these new age technologies, working as a mentor and a SME. So that being said, let's also have a quick look at why we are here today, right? So let me bring up these slides so that you can see. Well, this is supposed to be a demonstration session. So what is the idea behind the session is to get you familiarized with something called big data, and also introduce the bouquet of what you say services that are available along with big data and Hadoop, right? So before I proceed with the short introduction of big data, may I know whether you are already familiar with the concept of big data? You can either type it in the chat window or you can speak as well.
I have an IT background, but
how comfortable are you with big data?
No, I've been dealing with data, but that's this thing that you guys are talking about. So, should consider me as just a beginner.
So you're Nopal, right?
Yes.
Okay. So no worries. That's not a problem at all, because most of the people who are looking for a change, either in terms of a new project or a new job altogether into the world of big data, they are just beginners. So that won't be a big problem. So, so the idea here, as of today, is to give you a brief about big data, and then also give you an idea about the course that we have and how the course runs and what are the points we'll be covering and how we will be helping you to set up the lab and other kind of things, right? So without much delay, let me quickly give a word or two about big data, right? So this is part of the slides that we have, and what exactly is big data, right? So the first question that we have to address is, what is big data? Now, why this question is so relevant is because in today's modern era, like I said, whether you're looking for a new project or a new job altogether, or you want to learn something that matters, this buzzword called big data, or this keyword called big data, is all around us, right? Big data is everywhere, right? So you can Google it and you can find tons of information related to something called big data. So what exactly is this thing called big data? So many people have this confusion. They believe that big data means, huge amount of data, right? So the size of the data. So we end up having a lot of data to store, and we really don't know what to do. So that's called big data. Well, you are partially correct, I could say. It's not completely incorrect, but you see, big data is a problem, in fact. It's not a solution. Big data is a classic problem which we are trying to solve. So what is this problem and how we happen to end up in this problem? And why this keyword was not there, like, say, 10 years back. Say, imagine we were in 2005, 2006. We probably could have never heard about something called big data. Why? Because big data was not there 10 years back? Not exactly, right? Well, this term was actually coined by CERN, the European Research Agency, CERN, and they coined it pretty much back, like I think around 1980s or 1990s, they coined this term called big data. You see, the problem is very simple, right? The problem is very simple. If you imagine the world, say 10 years or 15 years back, right? We were creating softwares and computers were around and we were creating softwares, and these softwares were pretty much limited. For example, let's say I designed the software of an accounting software, imagine. An accounting software which is going to install in a retail company, something like that, a retail shop, right? So if you design such a software, what happens is that you typically follow the normal, how do I say, traditional software development life cycle, and you end up having a typical three-tier model. You will have a front end, you might have a middleware, and you will have a back end, which is a database where you store the data and retrieve the data. So these databases are as good as dinosaurs, I believe, right? Because ever since we started learning softwares, we learned database as well. Because we know that if you are using any kind of software, no matter whatever type of software you're using, you need a database where you can store and query the data. Or we call it as RDBMS. We call it different names. We call it as relational database. We call it as SQL. We call it as RDBMS. Whatever it is, we need a database where you can store and query the data traditionally, right? Now, this was really good, and we had a lot of players in this market, such as Oracle, MySQL, Microsoft SQL, DB2, etc. But over a period of time, what happened was that the world witnessed a tremendous change in terms of technology. You see, the internet became a mature model, and a lot of people started using internet as a platform, right? So what happened? We ended up having, a lot of online transactions. A lot of e-commerce companies came up, such as Amazon or, online shopping companies, etc. And we also started using a lot of social media for expressing ourselves, such as Flickr, Instagram, Twitter, etc., etc. And on top of all this, we also started using mobile devices. So mobile devices started to be an integral part of us. So if you look at the world today, we have everything. We have mobile devices, social media, which all keeps on generating something called data, right? So the overall data generation in the world has tremendously increased. So now we have a real problem. Now, in today's modern era, if a company want to, say, store the data, right? If a company wants to store and analyze its customer data, we are talking about all the different types of data which are coming from all these platforms, right? And once all these different types of data comes, your databases or traditional RDBMS will fail. So the problem here is that the RDBMS is designed to store data which is of one type, a single type. So what happens? You typically enter or you typically store data in the form of rows and columns into an RDBMS, right? So you have some sort of a front end, and there you insert the data, right? You get a what you say row and column type of data which you typically insert into an RDBMS, right? But what happens when you want to store, say, social media data, when you want to store, say, sensor-related data, when you want to store different types of data, your RDBMS cannot be a possible solution because of two reasons. The first reason is that the sheer size of the data is big, right? So you have now terabytes and petabytes of data coming in, which I cannot store in an RDBMS, right? The second thing is that apart from the size, the complexity of the data now matters. So you're talking about storing text, image, audio, video, all these different types of data, right? So that is the classic problem that we are facing. So how are you going to store and process huge amount of variety of data? And that is the big data problem. And like I said, big data is a problem. So every company who is into business, today want to make money, right? So why do companies do business? They want to get profited. They want to make money. Whether you're talking about the stock market or the retail or the banking or even healthcare, all of them want to make money. So how do you make money? You make money by getting more profit. And how do I get more profit? If I know my customers really well, if I can sell my products really well by knowing my customers, then I can make money, right? So to understand your customers better, the best way is to analyze the data that is being generated by customers. So just take a simple example. Imagine Amazon. You have Amazon.com, right? So what happens, say, when you visit Amazon.com? So you open up your browser and just type Amazon.com, and you land on Amazon's webpage, right? So the moment you land on Amazon's webpage, they start tracking you. They start capturing all sorts of data, from which city you are visiting, from which latitude and longitude you are visiting, and how much time you are staying on a particular web page, how many items you are clicking, what images you are zooming, how many items you are adding to the cart, are you clicking on a specific offer, are you checking for delivery options, are you paying with your credit card or debit card. All this information is tracked. All this information is tracked and stored. Now, Amazon says they get about 1 million visitors every hour, right? So that's close to 25 million visitors in a day, right? So imagine the amount of data you're collecting from them. Now, all this information is put into a system which can analyze this, and then it can predict the customer buying factor. For example, if you have ever used an Amazon app, right? The Amazon mobile application, or if you have an Amazon account, you can see that the moment you launch your Amazon app or the website, you get personalized feeds. You get item recommendations based on your buying patterns. You get selective offers, personalized offers. So all this is done by analyzing the data that you generate. So Amazon, in fact, captures your site traffic, which is what you leave when you browse Amazon's website. It also captures the data from your social media platforms, the data that you generate from your mobile app. All these things are captured. And then it is stored in a system such as Hadoop and then analyzed to predict customer spending patterns. For example, if say 7 out of 10 customers from New York are searching for iPhone 7, then it is probably a good idea to show an iPhone 7 banner on your website so people will click and buy. Or say, for example, if 8 out of 10 customers from San Francisco is searching for a particular brand of a mobile, something, maybe Apple iPhone, then it is a good idea to give, say, a 2% offer on iPhone so that people are going to buy. So you see, in today's modern era, the whole business runs on this, and that is why big data is important, right? So if you look at the traditional definition of big data, it says big data refers to data sets so large and complex that it becomes difficult to manage and process via traditional RDBMS tools. So that is exactly the definition of big data. If somebody is going to ask, like, what exactly is big data, right? So big data is a term which we say it refers to large, complex amount of information which cannot be handled by an RDBMS. So we are saying bye-bye to RDBMS, right? So that is one thing you have to understand. In the world of big data, you do not have RDBMS. We no longer use RDBMS. So because of the limitation of RDBMS, right? So look at the pointers we have. Every day we roughly create 2.5 quintillion bytes of data. 90% of the world's collected data has been generated only in the past 2 years. Isn't that a very interesting statistics? See, you see 90% of the world's collected data has been generated only in the last 2 years. So it is an exponential growth that we are facing in terms of data, right? And it keeps on growing. So data sizes are now in petabytes, terabytes, exabytes, and zettabytes. Now, you know what is a terabyte, right? So if you look at the graph, so you have a megabyte, gigabyte, and terabyte. So 1 terabyte is in fact 1024 gigabyte. And then you have the petabyte, 1 PB. 1 petabyte is 1024 terabytes. And you have exabytes and zettabytes. So today we are talking in terms of petabytes and exabytes. Why exactly has data generation increased? The advent of internet is the primary reason for the data explosion that has taken place over the last 15 years, right? So internet is the main reason why there is a tremendous increase in data generation, right? No matter what you are using, everything is online these days, right? Whether a shopping website or an app or a chat, everything is online. So the primary reason or the primary driver behind your data revolution is internet. This data explosion was encouraged because it provided very lucrative insights to businesses and social organizations. To give you some ideas as to how you can use the data, so a famous company, holiday destination company, what they do is that, so for holiday destination companies, it's an online portal. What happens? You click on the company's portal, and then you say that, hey, I want a 1 week holiday in, say, somewhere, Italy. So I'm planning a 1 week's holiday in Italy, and they're going to book your entire trip, right? So that's what they do. So what this company does is that, they start collecting data from the users who are, making reservations. And what they found was that if the user is using an Apple MacBook, okay, if the user is using an Apple MacBook to make a reservation, then they always prefer premium apartments, premium hotels, maybe 4-star, 5-star premium hotels. On the other hand, if the user is using an Android mobile phone or a Windows laptop, for example, then they don't prefer premium hotels, they prefer budget hotels. So you see, this is something which you can get only by analyzing the data. You can't just predict this. So the company started analyzing all the reservations they got for the past 1 to 2 years. So there were millions of them, And by analyzing this data and the user's platform, they figured out that, if the user is using an Apple MacBook, then chances are very high that he will go for a premium hotel, right? So this is called insight. Insight, lucrative insight. Insight means you are deriving data, you are deriving new business values out of the data that you have, right? So now, since the company understands that the Apple users prefer premium hotels, they can offer only premium segment to those users. So for example, if you access the company's portal using a, say, Apple MacBook, then they will show you only premium hotels. And they can even give a discount on that so that more and more users get attracted. So you see, this was something which you were not able to see without analyzing the data, right? So this is the key reason why people are more and more being driven to data analytics, right? So a development of new age technologies such as Hadoop, coupled with analytics tools, resulted in greater access to data even for SMEs, right? So I'm sorry. Another interesting use case in data analytics is for these e-commerce companies. So, for example, Amazon, right? So in Amazon, when you place an order, let's say you want to buy, what do you want to buy? I don't know. Let's say you want to buy a laptop, right? You want to buy a laptop, right? So let's say you buy a laptop, and you get multiple options with a laptop, right? So you can either pay using your card, using your bank account, or you also have something called cash on delivery, right? So you opt to pay once you receive the item. So that's called cash on delivery, right? So let's say that Amazon is offering cash on delivery on a particular brand of laptop, right? Now there is a hidden problem in this. What is a hidden problem? Say if a user orders a laptop and maybe, say for example, it takes 5 days to deliver the same. Now at the end of the 5th day, when you actually deliver the laptop to the user, there is a chance that the user may reject it. He may very well say that, well, I'm not interested, or I bought another laptop. So what happens? You are wasting your money here. You have to transport the entire laptop, so your logistics money is wasted, your tracking money is wasted. So you have to go all till the last mile to get a response that it will not be sold. So what's the problem here? The problem here is cash on delivery. So when you have cash on delivery, this will happen, right? But on the other hand, you cannot possibly remove this offer. You cannot say that we want to offer cash on delivery, because cash on delivery is an attractive offer for any customer, right? So people love it, in fact. So you can't remove it from your site. You have to do cash on delivery. But how do you know whether a person will actually buy it or not? That's a very interesting point about almost all the e-commerce companies. So what Amazon and other companies does is that they already have huge amount of data from all their customers. So they collect, like I said, their social media data and their app-related data, the website-related data. And all this data is moved into something like Hadoop. From there, they do something called data science. So there is a branch of analytics called data science. And data science is one of the most important branches of analytics, and the most in demand also as of now. So you have people called data scientists. So what they do is they take the data, okay, and then they create something called a predictive model. So they create a model, okay, in which they say that if you give this data, the model is going to predict what's going to happen. For example, they could have took all the data from the past purchases from customers, and now the model understands how many people rejected the cash on delivery product, how many of them accepted, from which part of the country they were, what was the reason for denial, and all these things are fed into the system. So now you have a data science model, right? So a model, or I can say a platform. So now before somebody actually places, or after somebody actually places an order for cash on delivery, what you do is that you can check the chances or the probability of the customer actually buying this using this model. So what you do is that say for example, today a customer placed an order for a laptop and he wants cash on delivery. So you feed the data into this model and the model can tell you whether the customer will actually pay when you give it or not. Well, it's not 100% correct, it's a probability, but still a good thought, right? So on a scale of 1 to 10, the model is going to say that there is a chance of, on a scale of 1 to 10, there is a chance of 8 that the customer is going to buy it. That means there is a high probability he will buy it. Or the model is going to say that based on the location and past buying patterns of the customer and also the common trend among the age group in which the customer falls, there is a chance of 2 that the customer might not buy this product. So then you can take preventive measures. For example, you can proactively call the customer and verify whether he is still interested in the product. If he is not interested, then why are you shipping the product? So you see, this whole business runs on analytics, right? So of course, data science is a whole different beast altogether, but I'm just giving you some examples, right? So data today is the most important commodity. If you harness your data, it provides an unmatchable competitive advantage. So if somebody asks you what is the most valuable asset you have today, it is data, nothing else. The entire world runs on data. So I can give you thousands of examples. I mean, there are a lot of examples. So I guess most of you are joining from US, so you might be familiar with services like Netflix, right? So you have something called Netflix, right? So what is Netflix? Netflix is an online streaming service, right, where you can watch movies and series and all those stuff, right? So that's called Netflix, right? So Netflix uses big data heavily, right? Now, why Netflix is using big data? See, what happens is that so how does Netflix work, right? So they commission a series and they invest millions of amount in a series, right? And then they broadcast the series to make money. So that's how they work, right? For example, you have House of Cards, right? So Netflix will commission the next season of House of Cards. Of course, the season 4 is about to come. And so they are investing a lot of money into that. And while the series streams, users pay money and watch it, and they make money out of it. So the most important part here is to figure out what the customer actually want to see, right? If you ever host a flop show, then the customer might not like it, and chances are very high they may not even come back to you for other shows as well. So how do you decide what customers really like, right? So Netflix uses big data heavily. So what they do is that they collect real-time statistics about your views, because you watch Netflix using internet, right? So they can understand what are you watching, not you, millions of customers across US, imagine, right? So they understand what genre you are interested, what kind of a storyline you are interested, right? Are you a fan of horror series or comedy series or whatever it is, right? And then they also analyze your other patterns, like how much you want to, for example, how many months subscription you have. Are you tweeting? Are you posting tweets or a Facebook post about a particular series, right? So from all this, they come to understand your behavior, right? Based on that, they commission the new series. Now, I'm not joking. You can Google for this. There is a series called Narcos in Netflix. If you ever watch Netflix, you will be a fan of this. Narcos is a series, right? I guess the first season is over. It is the real life story of the drug dealer Pablo Escobar, right? So before Narcos was commissioned, Netflix did a survey, based on big data analytics, and found that the right recipe for a premium hit series show for the users is drugs, then violence, then what you say, some action and adventure and some hero character. So they figured out by analyzing your data, and based on that, they created the series called what you say, Narcos, right? You can Google for that. Just type in Google Narcos plus big data. So the entire series was created by keeping the interest of users in the mind, and it became one of the biggest hits for Netflix. No wonder. So you see, it is like understanding your taste without you revealing that to someone, right? So it is very important. So that is why we say that data is the biggest commodity today, right? Millions of dollars or billions of dollars are spent in this business of data analytics, right? Couple of simple use cases in big data. So one of the examples that we have is Walmart. Walmart is the biggest retail store chain in the world with close to 11,500 stores in 28 countries around the world under 65 different banners globally. In 2015, Walmart handled more than 1 million customer transactions every hour, which it imported into databases estimated to contain more than 2.5 petabytes of data. So you see, Walmart handles more than 1 million customer transactions every hour, and they have more than 2.5 petabytes of data on a monthly basis, right? So it is really important for Walmart to analyze this data to predict things like, how they can better serve the customers. For example, let's say there is a Walmart store in San Francisco and the sales are dropping. People are not buying things. Now, why is this happening? So if you want to know why people are not buying from you, then you should analyze the data. That is the only way. Otherwise, how are you going to analyze 24 million transactions in a day and come up with a solution? You cannot do this. It's impossible unless you use a big data technology. So Walmart is one of the biggest users of Hadoop and big data. So they use it for almost everything. And of course, the next classic example is of Facebook, right? So we have Facebook, so you might be familiar with Facebook. So as of the third quarter of 2015, Facebook had about 1.55 billion monthly active users, in excess of 100 terabytes of data uploaded daily to Facebook. So Facebook gets around 100 terabytes of daily data. Can you imagine? 100 terabyte every day, right? And it stores, access, and analyzes 30 petabytes of user-generated data. Now, the way in which Facebook uses the data is mostly for its advertisements. Well, this is better explained in our full-blown course as well. So when you log into the Facebook page, you see the advertisement, right? So for the millions of active Facebook users, they can show the active advertisements, and that is done using this, right? So having said all about big data so far, it would be a nice idea to talk about the course that we have, and also what are we going to cover in the course, and etc. etc. So just give me a moment, let me do something. So let me quickly bring up an image so I can talk. Hadoop to ecosystem. Well, so I have not talked about Hadoop so far. The reason for that is it's not either the time to talk about it, or in a better way, we need more time to talk about Hadoop, right? So you see this keyword called Hadoop everywhere when you refer to big data. So typically people, Google for big data and try to see what is big data and all. You often see another term called Hadoop as well, right? So we say big data Hadoop. So what is Hadoop? Well, Hadoop is an Apache project. Okay, it is a framework which is designed to efficiently store and process big data. So Hadoop is the solution to big data problem, right? So if you want to store and analyze big data, then one of the best possible ways to do that is using Hadoop. Well, there are other tools as well. Hadoop is not the only tool which can store and analyze big data, but Hadoop is the most popular tool among all other tools, I can say, right? So we have a course, in fact, in which what we teach is we teach big data plus Hadoop, right? So we start with the introduction to big data, and we learn big data in much more detailed fashion, what it is and how it is used, etc., etc. And then we introduce this concept of Hadoop. So in Hadoop, we talk about the architecture of Hadoop. We will learn about the installation phase of Hadoop, right? And then, so you see, another interesting thing about Hadoop is that Hadoop itself is actually a solution to store and process big data, but there are a lot of other tools which you can use along with Hadoop. So you see some of them here in this picture. You see something called Pig. You see something called Hive. There is something called MapReduce, there is Yarn, there is HBase. So these are all the tools which you can use along with Hadoop to analyze big data. So in our course, what we do is that we generally talk about introduction to Hadoop, architecture of Hadoop, and then we move to something called MapReduce. You can see MapReduce, distributed processing here. Now, MapReduce is the default programming framework that we have in Hadoop. So we will learn the basics of MapReduce. We will also learn to create programs using MapReduce. Now, MapReduce program is one of the highlights of every Hadoop implementation. So if you ever want to store and analyze big data using Hadoop, then one easy way to do that is by using MapReduce. So we will learn MapReduce. We will write codes using MapReduce, and we will analyze the data also using MapReduce, right? And once we are done with MapReduce, we will move to something called Pig. Now, Pig is a scripting language we use on top of Hadoop. We learn Pig, we will analyze the data using Pig and all. We also move to another tool called Hive. Now, Hive is a query language, something like your SQL, right? So we'll install Hive, start using Hive, and then see how Hive works on big data, etc., etc. Apart from this, we also have two more tools called Scoop and Flume, which is not there in the picture. So Scoop and Flume are kind of data transfer tools we use in big data. And last but not least, we also talk about something called HBase. Now, HBase is your non-relational database, or we can say it's the NoSQL database we use on top of Hadoop. So we learn what is HBase, how to use HBase, and all these concepts will be covered in the course, right? So to give you some perspective as to what we'll be doing, so the biggest question that people usually have is that, all right, so I understand that we can learn big data, we can learn all of this, but how are we going to try this hands-on, right? So we can provide you with a pre-configured virtual machine. So what we can do is that we have a virtual machine in which Hadoop is already installed along with other ecosystem tools, and whatever examples we will be demonstrating. So you can use the same virtual machine to practice as well. Let me show you the virtual machine. So this is the VM we have. Just give me a moment. I'll just start it. So this VM is installed, in this VM, Hadoop is installed on top of Ubuntu, right? So typically, whenever you see a Hadoop installation, seriously, when you ever look at Hadoop implementation, most of the Hadoop implementations are on Linux platform. So this is a Linux platform that we have. So let it some of the real-time data sets. So since we are anyway doing a demonstration, let me also quickly demonstrate one more thing. Oops. Give me a moment, okay? Let me see whether I can log in here. Yeah, so let me quickly show you some of the things that you can do with Hadoop that might be really interesting, right? So one thing that people usually do with Hadoop is, I mean, we have not learned anything about Hadoop so far, but just to give you some idea, one thing that people are usually interested in doing with Hadoop is, uploading structured data and then querying the data. So what if you want to upload some data and query the data, right? So let's try to do that. Let's try to take a sample data set and then try to upload the data and then see whether we can actually query the data, right? So what I'm going to do here is, I already have a Hadoop cluster running, so let me connect to that. So this is a web tool we use for connecting to Hadoop, so it's not a big deal actually. Oops, only thing I forgot the username and password, so let me copy this. Okay, so I'm just accessing a Hadoop cluster here, so that's what I'm doing here. So this is my Hadoop cluster. You may not be able to see this for the time being because we have set it up. So before we actually do this, let's see what we are about to do, right? So what is that we are going to analyze and all. To show you that, let me show you the data we will be working with. So if I come here, there's finance data set. Yeah. So you might be aware of the New York Stock Exchange, right? Or we call it as NYSE, the New York Stock Exchange, right? So we have some sample data from the New York Stock Exchange. So it's this data. So let me open this. It is a spreadsheet, and let me show you the data as well. Let it start. I think it is taking a bit to open this. All right, so here we have. So this is the data. This is the real data, in fact, which we have collected from the New York Stock Exchange. And what is this data all about, right? So let me show you. For example, the first column is the exchange name. So it is NYSE, which is New York Stock Exchange, right? And the second column is ticker. Ticker means, the stock name. You have stock, right? So AEA is one company. And the third column is the date. So the date of analysis, when we collected the data. Then you have opening stock, then closing stock, then average sale, maximum, total volume, etc., etc. So what is the opening value of the stock? What is the closing value? What was the max value, min value of the stock? Everything. Right? So this is how a typical stock exchange data will look like. Now, if I do a Control A here on this data, right? You see at the bottom of my page spreadsheet, you see the count. Okay, so let me figure out. One, two. So this has around 6 million rows. So you can see very well at the bottom. So this data has around 6 million rows. So can you imagine a spreadsheet with 6 million rows? And what if you want to analyze this data? What if you want to analyze this data? Right? So if you want to analyze this data, you can easily do that using Hadoop. So before I do that, let me also do one more thing. So I will have here, just bring this. Okay. So just give me a moment. Where is WordRAM? Okay, so what we need to do here is to create a table out of this data, right? And then what I'm going to do is, so here is my Hadoop, and Like I said, you may not be familiar with this, but let me just walk you through what I'm going to do. So what I'm going to do here is that I'm going to create a new folder first of all. So I'm going to say new directory, and I'm going to create a directory called Hadoop, something. So say create. And once I have the directory called Hadoop, I'm going to go inside the directory, and then I'm going to upload the data. So upload files. I'm going to select the file, which is somewhere in, I don't know, let's see, speed, projects, finance. All right, so here is our data. So I'm just uploading the what you say spreadsheet that we have just seen to Hadoop. So basically we are uploading this to Hadoop. So you see the size of the spreadsheet is around 39 megabytes, right? So it might take a moment for uploading the data. All right, so the data is available now inside this folder, right? So you see now what I can do is I can create a table from this file. So what you need to do here is that we are going to use a tool called Hive. To do that, we have to create a table. So I'm going to select database by name. Okay. Then I'm going to say create a new table from a file. So I'm going to give a table name such as see, we give the same table name maybe. So NYSE1, let's say NYSE1, right? And then you're going to select the file that we just uploaded. So where is the file? Hadoop. There's the file. And then we're going to say next. And then we have these columns. Okay, so that's fine. So we have the data like this. Say next. So we're going to say stock symbol and stock volume. Let's see. Stock symbol, and then you have stock volume. So this is going to be stock symbol. I'm just giving a name for the column. Okay, so this is stock symbol and this is stock volume. Then, oops, sorry, volume. Then you simply say create the table. So what this will do is it's going to create a table and dump this 7 million values into the table. Right? So now we have the table with us, right, inside Hadoop. Then what you can do, you can go to this tool called Hive. So this is a tool called Hive. I can go to this tool called Hive. And here, what I'm going to do, I'm going to select my database, which is Raghu. Okay. And let me refresh this. It should have NYSE1. I guess so. Then I can simply run my query. So let's see. So first let me run this, then I'm going to tell you what I did. Execute. Might take a moment. Very interesting. What happened? So let me check. So let me just check what happened. Okay. So we're gonna say meta sort tables. I'm gonna say the table called NYSE3 maybe. Let's see whether this table exists. Sample. Okay, it's there. So I'm going to come back here. And I'm going to paste it here, and maybe it is NYSE3. NYSE3. Say execute. Oops, my bad. Okay. So let me figure out what happened. Sometimes it happens. I think the data is not properly loaded, right? How can you do that? Just click on this NYSE1 and you can go to sample. Very interesting. So for some reason it could not load the data, right? So for some reason it could not load the data. No worries. Let's do one thing. I have already loaded the data using another table, right? So let's select the other table, which is NYSE3, and this might have the data. If I look at this sample, NYSE3 has it, and you have stock underscore symbol and stock underscore volume. So if I try to run this, it should work, right? NYSE3. Let me just check. Yeah, here you go. So, there was some problem loading the data, so that's what I did. See, what I did, I came here, I did select stock underscore symbol, comma, sum of stock volume. So I want to know for every stock, what is the total volume of trade from NYSE group by stock volume. So it's a regular SQL query. But the point that I'm trying to tell you is that immediately when I ran the query, I got the result. So you see all the stocks and their total volume. So you might be thinking that, well, this is not a big deal, right? It is a big deal because if I look at the log files, somewhere it might be there. Query, log, result, chart. Well, you could have figured it out by this time that this query took around 3 seconds to execute, right? So you were able to analyze 7 million rows in 3 seconds. Now that is a big deal, right? So this is where the application of big data actually comes into picture. So when you have these type of data, where you have millions and billions of rows, and you want to run queries and analyze the data, well, queries is one way. I'm not saying every time you'll be doing queries and all. Then the best way to do that is using something called Hive. So that is what we did. So we were able to analyze and find out the total trade volume per stock for about 7 million trade queries using just Hive in 3 seconds, right? So that is where the application of big data comes. Well, I just wanted to show you something, so I just showed this. Well, this is not the only thing you can do with the Hive or Hadoop. There are much more interesting things, right? And I also wanted to show you that we'll be working on real-time data sets. So for example, this is a real-time data set, right? I'm not saying some sample data, it's an actual data, right? That we will be figuring it out, right? So this actually marks the end of the demonstration for today. So if you have any specific queries, I will stay back. You can ask me and I will answer them as well. So just let me know if you have any specific questions.
So hi Nupur.
Anything at all?
Yeah, Nupur, do you have any questions?
No, I'm fine. It was I got pretty much got everything.
Okay.
What about Sindhuja? You are okay? You have any queries regarding this? And Sivatesh, what about you? You have any queries regarding this?
What is it? No, I'm fine.
Okay. So do you want to know more about the course and details? What you're gonna do further in the when you start up the sessions and everything?
This is Nupur here. I'm so sorry. I have just one question. So you showed us Ubuntu. So are we going to do our sessions in Ubuntu or are we going to do it in AWS?
No, you can do it on AWS, but that will be chargeable. So I don't want to say spend additional amount. When you use it on Ubuntu, it's free completely, right? AWS will charge you over a period of time anyway.
Okay.
So we'll be doing on Ubuntu.
So seems to be guys are comfortable after having all this knowledge. I think they don't have any queries. Is that so?
Mm.
Did we? I know you did quickly flash the slide of the topics. Can we see that one more time?
Oh yeah, sure. I mean, give you a minute. In fact, let me show you another slide which actually talks about the topics in detail. Just let me figure out where is the slide. Give me a moment. Somewhere here we'll have it. Just one moment, Nupur. I'll just bring up this slide.
If it's too much of hassle, then maybe we can get it later. Then
No, it's okay. No, I have it. I'm just trying to figure out where it is. There's a different slide where it says, the course modules that we'll be covering. Right? So that is what I'm trying. Just one moment.
And I had one more question. So after this Hadoop training, you quickly, briefly mentioned it about data mining. So how close are those two to each other? Is that a separate training by itself?
Well, yes, data mining is a separate training altogether, but these days Hadoop is very much used in the same place as well. So once you have the knowledge of Hadoop, it really helps you to how do I say move better in the direction of data mining. Data mining is a different course altogether. So these are the modules that we have. I just wanted to show you, quickly what we have.
Also, does it include any programming in Java during this program?
Yes, yes, I was about to say that when there is something called MapReduce in Module 3 and Module 4, we'll be talking about MapReduce. So MapReduce requires basic Java knowledge, core Java knowledge.
Okay, and would we be programming or something, or so does it have any project or anything like that, or would you be demonstrating Java a program that typically that we come across?
I'll be demonstrating, and I'll be also sharing the same with you, the code snippets and all. So you can try it yourself, and we can also do a project. Okay, so typically how this works is that we'll do some real-time projects on all this. So for MapReduce, we have a real-time project. For Hive, we have a real-time project. For Pig, we have a real-time project. Because if I just show some very basic sample things, that's not how the industry works, right? You want to know how this is actually used in the industry, right? So you want to know, if I get some real data, how do I do it with this? So I will be showing that, and I'll be sharing that with you also. You can also do that.
Okay.
So let me know if any more questions are there.
So the platform where we'll run this Hadoop, so MapReduce, or basically this Hadoop framework, is it installed in some VM, or do we get to install our own? I don't know if the access to that is like, are they open source completely where everyone can install their own? And
Hadoop is completely open source from Apache, and you can install it by yourself if you want. There is no problem with that, but the installation of Hadoop and other ecosystem tools are slightly complicated. So usually what we do is that, since it is a developer course, we provide a VM where that will be pre-installed. I can show you the installation steps and even show you how to install it from scratch during the course, and you can try it on your own, maybe on a different machine. But for doing the hands-on, I suggest using the VM, because that will have everything set up in a nice way.
Okay, that's good. So by development you mean so what will we be actually developing? So from programs point of view or scripts, or what will we be writing? Like for example, would we be writing a Java program or something during this program? Or?
Yes. In MapReduce, it is Java. MapReduce is built on top of Java. But when you come to Pig, Hive, or HBase and all, they don't use Java or anything. They are having their own, how do I say, syntax. So Pig, Hive, and HBase are there. I mean, new to somebody who has not come to the world of big data. So they have their own syntax. It's not a program, I should say. How do I say? For example, Hive is a query language. So in Hive, we'll be writing queries. And Pig is a scripting language. So we usually write Pig script. And HBase is a database. So it's not a language, I can say. It is a way you develop. So these are all tools you can use on top of Hadoop. And if you're learning Hadoop, then you must be familiar with this. Otherwise, there is no point in learning Hadoop. Right? If somebody asks you, like, what have you learned on Hadoop? Then you must say that I know Pig, I know Hive, I know HBase. So those are the things which are being extensively used. Okay.
Okay. And so for the MapReduce, so typically is it rare to write your own programs for the MapReduce processing, or is it like there are pre-built libraries that typically people just use those from off the shelf?
The libraries will be available, but the programs definitely you have to write. For example, if it is a Java code, you can use inheritance and all, but ultimately the logic and the code you have to write. So for any program, just like any other program, you have to write.
Okay. And so being a Hadoop developer, so people do develop Java programs on like a daily basis.
Yeah. So in MapReduce, in fact, you can use multiple languages. For example, Java is one. You can also use Python, PHP, C#, Ruby, all this. But one reason is I'm comfortable with Java. The second reason, most of the MapReduce codes are in Java. So it's not like you can use only Java. You can use other languages as well. But mostly people prefer Java because it is so common. Everybody might be knowing Java. But if I say Ruby, then most of you might not be knowing Ruby, right? So that is why we stick to Java.
Okay, I'm trying to assess how much percentage of daily work or is really the programming part aspect.
Oh, okay. No, that won't be much, and we'll be sharing the code snippets. So you won't be writing.
Not the program in general. In general, the jobs after the training and all. How much percentage is on a daily basis typically?
It depends on the role. Yeah, it depends on the role you actually fit in. For example, if you're a MapReduce developer, then yes, you have to write programs. If you're a Pig developer or a Hive developer, then it might not be a program. It might be a script or a query. So that depends, on the situation.
I see. Okay, so there are some roles in this. It's not just Hadoop developer. So there is a full stack. This is the full stack Hadoop, I guess, right? The Hive, Pig, and everything.
Right.
And typically the roles are specific to a module. Is that how it works in the industry?
For a Hadoop developer, this is all the modules we have, and mostly the demand is for Hadoop developers. But you also have analyst people. So if you're a Hadoop analyst, then you will be using only Pig and Hive. You will not be using MapReduce or anything else. You will stick to Pig and Hive. Then we have these data scientist folks. That is a whole different arena. So if you're a data scientist, then you will be mostly dealing with statistics, algebra. You have to learn all you learned in your 10th and 12th, so complete aggregation and all these things. Maths, basically very good at mathematics. And then you have to learn languages like R. There is a language called R. So you have to learn R. So those are folks who are mostly towards data science. So you have a role called data scientist. You also have a Hadoop administrator, just like a server administrator, So you have the Hadoop administrator who is not a programmer or something, who is actually into managing a Hadoop cluster, So like installing, managing, configuring,
And so map, so being, so the, I guess, three roles at a high level that you mentioned. So the one that this training is about is the Hadoop development role, developer role, and which includes all these modules as part of the job, in general a role,
Yeah.
right?
Right.
Okay. Okay.
Okay.
Are we done for the day? For the night? Sorry, our night, your day.
uh,
I think we are done.
so,
Okay.
Nupur, I will send you the content core curriculum, what we're going to discuss in the part of training and everything. I will send you detailed things in my next mail.
Sure.
Okay?
Sure, we'll talk.
Yeah. So have a nice day, guys.
Yeah.
So thanks one
Okay.
and all.
Thanks.
Thanks one and all for joining the session.
You all are very happy Diwali.
Yeah, happy Diwali by the way.
You too.
Siva, thanks for joining. Sunuja, thanks for joining.
Bye.
So I hope you like the session. So is that I can